Hello everyone, in this video we will see about the characteristic table and excitation table of D flip-flop. So this is the truth table of D flip-flop. When there is no clock pulse, irrespective of the value of D, Qn plus 1 will be equal to Qn. And when there is a clock pulse applied, then the value of Qn plus 1 will be equal to D. If we are applying 0 at the D input, then we will get 0 at the output. And if we are applying 1 at the D input, then we will get 1 at the output. So this is the truth table. Now we will see the characteristic table. So in characteristic table, we will take the present state and input, that is Qn and D, and we will take the next state as the output. So there will be 4 cases corresponding to Qn and D. So 0, 0, 0, 1, 1, 0 and 1, 1. So for this 4 cases, we will find the value of Qn plus 1. So when D is 0, in all these cases a clock pulse is applied. So when D is 0, whatever be the value of Qn plus 1 will be equal to 0. And if D is 1, then Qn plus 1 will be equal to 1. And again then Qn becomes 1, then again D is 0. So since D is 0, Qn plus 1 will also be equal to 0. Qn plus 1 will be equal to 0. Now D is 1 here. So Qn plus 1 will be equal to 1. Irrespective of the value of Qn, the value of Qn plus 1 will be always equal to 1 when D equal to 1. So this is the characteristic table. Now from this table we can see that Qn plus 1 is equal to D itself. So Qn plus 1 and D are the same. So there is no need to draw the K-map. We can write directly the characteristic equation, that is Qn plus 1 is equal to D. Next is the excitation table. In the excitation table, we will take Qn and Qn plus 1, that is the present state and the next state, and we will write the input corresponding to that for each transition of the states 0, 0, 0, 1, 1, 0, 1, 1. So from this characteristic table we can see that when Qn is 0 and Qn plus 1 is 0, D is 0. Next is Qn is 0 and Qn plus 1 is 1, D is 1. Next is Qn is 1 and Qn plus 1 is 0, D is 0. And when Qn is 1 and Qn plus 1 is 1, D is 1. So this is the excitation table corresponding to D flip-flop.